Okay, so next one, BD. Okay, this is another non-right angle trig question. We're trying to find BD. We know, well, the question involves two angles, two sides. Note these angles here must be in radians. It actually tells us it's radians as well. So if we're trying to find BD, so we're going to use the sine rule. Do I need to remind you what the sine rule is, maybe? We find it. Yep. Remember, you're only going to be using a small portion of it. So BD over sine of the angle opposite it would be 1.75. It's going to be equal to the length we've been given, 7 over sine 0.82. So BD is going to be 7 over sine 0.82 multiplied by sine 1.75. Again, it's in radians, so our calculator has to be in radians mode. So sine, I forgot what it was already. 7 over sine 0.82. What equals 7 over sine root above 0.82 multiplied by sine 1.75. 9.42 to 3 significant figures. Okay, again, we are in centimeters units. So find angle DBC. Let's see where DBC is. DBC. So we're looking for this angle here. We've just found this length here to be 9.42. Let's have a look at this, 9.4206. So if we can, let's try and leave this as accurate as possible, 9.420. We'll just use that value, actually, let's do that. So we're trying to find this angle here, we're using the cosine rule, but this time we're using the angle version, so this one here. So again, if we're trying to find this angle, the length opposite it is the one that's going to be subtracted. So we would say cos theta equals a squared plus b squared. So our other two lengths, so we're going to be subtracting this one. So it's 9.42 squared plus 8 squared. Subtract, what was it, 12? 12 squared over 2 times 9.42 times 8. So alpha y equals 9.42 squared plus 8 squared subtract 12 squared over 2 multiplied by 9.42 multiplied by 8. And then obviously we need to inverse that because that's the cosine of the angle. So second cos second in F, which gives us 1.51. So theta equals 1.51 radians. Lovely. Find the y-intercept. So we're going to input this into our calc. So it's e to the 0.5x minus 2. Gosh, we know I'm going to forget that. Okay, so y equals, let's go to this one. E to the, oh, got no ready. 0.5x, 0.5 then subtract 2, make sure that it's written properly here. If we're going to be sketching it at some point, let's look at which window we're looking at. So minus 4 to 4 in the x-axis. Actually, maybe I'll go to 5. So negative 4 to 5, and then negative 3 to 7. So window negative 4 to 5, and then negative 3 to 7. Graph it. And what do we want to find? We want to find the y-intercept. So that's this value here. So calc find 5. So first curve. Does this work? No, it's not going to. Are we happy that this is just negative 1? Hopefully. We'll have it's negative 1. Okay, let me make sure that you're happy with it. Alright, so y-intercept happens when x is 0. So let's put 0 into there. E to the 0.5 multiplied by 0. Subtract 2. E to the 0, subtract 2. We know anything to the power 0 is 1. Subtract 2 is negative 1. So the y-intercept is negative 1. That's better. Find the x-intercept. That's when the y value is 0. So we can go, actually that's the calculator here, and do second calc 0. So we want 2. Go left bound. Right bound. And that's 1.386, so 1.39. Write down the equation of the horizontal asymptote. And go back to this, but we can see that it gets very, very close to this, but doesn't actually touch it. So that's y equals negative 2. It must be an equation, so it's y equals negative 2. Sketch the graph, so literally we just need to sketch the picture. As I said in paper 1, so you need to make sure that you're actually sketching the main points and make sure that it does actually look like this. So we can't go below negative 2, and it goes through the point here at negative 1, and we just said that this is 1.39, so try and make those points. So we know it goes through there. 1.39 is probably about there, and we know we've got a horizontal asymptote here, so oh gosh, that's a bit dodgy, but there we go, that's so far, and let's check the rest of it. So at 1, 2, 3, 4, at the value of 4, we're looking at between 1, 2, 3, 4, 5 and 6. So 4, we're looking at about between here, 5 and 6. So there's our curve there.